So today we're going to talk about Pythagorean theorem. On the top of your notes template is the definition of the Pythagorean theorem. This theorem applies only to right triangles. It says that the square of the lengths of the hypotenuse, C, so here's my hypotenuse, is equal to the sum of the squares of the lengths of the legs, A and B. So here's one leg, we'll call that A. Here's another leg, we'll call that B. And the legs always form the right triangle of the right angle of the right triangle. So when you're applying the Pythagorean theorem, you have to know two of the three sides. And in this given right triangle, we happen to know one of the legs is 5 centimeters and the other leg is 12 centimeters. And again, I know that those are the legs because they form the right angle of the triangle. I'm going to use the Pythagorean theorem to find the length of the missing side, which is the hypotenuse C. The first thing I want to do is I always want to write out the Pythagorean theorem, which is a squared plus b squared equals c squared. And remember, this is an exponent of 2. It's not multiplying everything by 2. So you want to be cautious about that. Now I'm going to do my plug-in, where I plug in what I know about the triangle. I know that one of the legs, and we'll just call the leg of 5 centimeters leg A, and I know the length of the other leg, which is leg B. So I'm going to plug those into my formula. I've got 5 squared plus 12 squared equals c squared. I'm going to go ahead and find the squareds of both of those values. So 5 squared gives me 25, 12 squared gives me 144, and again, I don't know what c is. So I'm going to go ahead and add 25 and 144, and that's going to give me a sum of 169. And that still equals c squared. Now to find the length of the hypotenuse, I just want to find what plane C is. I don't want to know what c squared is, which is what I know right now. So in order to undo the power of 2, I'm going to take the square root of 169, and that's going to tell me what c equals by itself. And so the square root of 169 is going to give me 13. So that means that my missing side of this right triangle, which is the hypotenuse, is 13 centimeters long, and I'm going to remember to put units on it because it is a word problem. Okay, taking a look at problem number 2, I have another right triangle that I am trying to find the length of one of the sides. It's marked X in your notes. I know that this side is one of the legs because it's one of the sides that forms the right angle. So I actually have this time the C value, and one of the legs, I'll just call it A, and the missing value I'll call B, which is another leg. So I'm going to write my Pythagorean theorem, and I'm going to plug in the values that I know. I know A to be 24. I don't know what B is. And I know C is 25. So I'm going to square that as well. Doing the math here, 24 squared is going to give me 576 plus the B squared, and 25 squared gives me 625. Now to solve this, I need to get B squared alone on the left side of the equal sign. So in order to do that, I'm going to subtract the 576 from both sides. These cancel out. I have b squared equal to, and 625 minus 576 should give me 49. Now again, that's what b squared is. I don't want to know what b squared is. I want to know what just the length of b is. So to find that, I'm going to take the square root of 49, So that means that my missing leg of this right triangle is 7 meters long. Now the Pythagorean theorem is actually useful in real life, and we're going to take a look at a word problem using the Pythagorean theorem. We are told that a 13-foot ladder is placed 5 feet away from a wall, and we want to know how high up the ladder meets the wall. So the first thing you want to do on your diagram is you want to go ahead and draw the right triangle. And we're going to mark what we know. Here's my right angle. I don't know this side. I'm going to call it side A. I know this side, and it forms the right angle, so that is a leg, and we'll call it side B. And I don't know this length of this side of the right triangle, which is the hypotenuse, which is 13 feet. So again, I'm going to write my Pythagorean theorem, a squared plus b squared equals c squared, and I'm going to plug in what I know. I know the length of b, I don't know the length of a, so I'm going to leave a squared as a variable squared. B is 5. C, the length of the ladder, is 13, so we're going to square that as well. That's going to give me a squared plus 25 equals 169. Remember that you are raising them to the second power and not multiplying by 2. I want to get a squared alone on the left side, so I'm going to subtract 25 from both sides. And these cancel out. Now I've got a squared equals 144. I'm going to take the square root. So the length of my missing leg of my right triangle is 12 feet. And because this is a word problem, you're going to want to make sure that you write your answer in a sentence with units. So to answer the problem, I'm going to say that the ladder met the wall 12 feet up from the ground. Another real-life situation involves a rectangle, and this one we're told that a suitcase measures 24 inches long and 18 inches high. What is the diagonal length of the suitcase? The first thing you're always going to want to do is you're going to want to draw a picture when you're not provided one. So here's my suitcase, and I know that we're talking about one of the lengths of the sides is 24 inches, and one of the lengths is 18 inches. Now, I don't have a right triangle here until I draw my diagonal across the length of the suitcase. Here's my right triangle, and I was told the lengths of each of the sides that make up the right angle, so therefore they are the legs of the right triangle. Plugging into my Pythagorean theorem, I have 18 inches for one of them, and I'm going to square that, plus 24 inches for the second leg equals c squared. 18 squared gives me 324. 24 squared gives me 576. And we're trying to find the length of the hypotenuse squared. 324 plus 576 gives me 900. And if I want to know what just the hypotenuse is and not the hypotenuse squared, I need to take the square root of 900. Square root of 900 is 30 inches. And again, it's a word problem, so I'm going to want to write a sentence, something like the diagonal length is 30 inches. We can use the Pythagorean theorem for more than just finding the length of a missing side. We can also use the Pythagorean theorem as the converse of the Pythagorean theorem, which basically just says if you take the sum of the squares of the legs, if that is equal to the square of the hypotenuse, then the triangle is a right triangle. So basically, if we plug it into the Pythagorean theorem, a squared plus b squared equals c squared, and everything checks out, and it looks to be like a check where we get something true, like 10 equals 10, then we know that the triangle that we're examining is actually a right triangle. So let's take a look at some examples where we're going to use the Pythagorean theorem to allow us to check if a given right triangle is actually a right triangle. So we're given 3 side lengths. For example 5, we're going to look at 5, 12, and 13. And if you read the hint that's given in the directions, you want to make sure that you're using the 2 smaller sides to be the legs, because the hypotenuse, or the side C of a right triangle, is always the longest side. Therefore, in example 5, 13 has got to be my C value. So when I plug it into my Pythagorean theorem, which again I'm going to write out, a squared plus b squared equals c squared, I'm going to plug in 5 for A, 12 for B, and C has got to be 13 squared. 5 squared gives me 25, 12 squared gives me 144, and 13 squared is 169. If I combine 25 and 144, I get 169. So like I was saying before, if it looks like a check and you get a true statement, then you know, yes, it is a right triangle. Let's take a look at another example. Let's take a look at a right triangle where our sides are 15, 36, and 39, which means C has got to be 39. If we plug it into our Pythagorean theorem, we've got 15 squared plus 36 squared equal to 39 squared. 15 squared gives me 225. 36 squared gives me 1,296, and 39 squared is 1,521. If I combine the two numbers on the left, I get 1,521, which equals 1,521. So I know that that checks out, and yes, it is a right triangle. Looking to example 7, I've got 2 legs of 5 and 7, and 9 is my hypotenuse, or C value. If I plug them in, I'm going to get 5 squared plus 7 squared equals 9 squared. 5 squared gives me 25, 7 squared gives me 49, and 9 squared gives me 81. Combining on the left, I'm going to get a total of 74, which does not equal 81. So this tells me that the lengths of these sides that they gave me do make up a triangle, but it is not a right triangle. Because again, Pythagorean theorem is only really good for right triangles. It doesn't work for others. Taking a look at example 8, I have got the lengths of the sides are not in least to greatest form. So I'm going to go ahead and list them from least to greatest because I need to know which one needs to be my C value, which happens to be 41. Plugging into the Pythagorean theorem, and yes, I'm writing it every single time. It helps commit it to memory. I'm going to take 9 squared plus 40 squared and set that equal to 41 squared. 9 squared being 81, 40 squared being 1,600, and 41 squared being 1,681. When I combine these, I do get a true statement. 1,681 does equal itself. Therefore, I know that yes, this is a right triangle.